Welcome to our review on forces and motion. So first thing we're going to do here then is just recap on a few forces that hopefully you do remember from lower down in school. So all we've got there in those images are just a few different examples of the forces that you'll encounter. So just a reminder for you, we've got push, pull, twist, gravity, weight, air resistance, friction, thrust and upthrust as different types of forces. When we're talking about forces, basically what we need to understand in P3 is how those forces actually affect the motion. So what we'll see there is a force is basically something that changes an object's motion. Now, if we apply a force that's in the same direction that the object is moving in, then the speed of that object is going to increase. If, however, the force that we apply is acting in the opposite direction to the motion, then its speed is going to decrease. The only other possible scenario we could see there is that the force acts in a different direction, and at that point we'll see it change in direction, so turn for example. When we're looking at any diagrams that have arrows on there and we're talking about forces, then that arrow tells us two things. One, it tells us the direction the force is acting in, pointed out by the arrowhead, and the size of the arrow then tells us the size of the force. So what we've got in that diagram there then are three different vehicles. We've got our lorry, which is 8,000 kilograms, our car 1,200 kilograms, and the motorbike 600 kilograms. Now they all have the same force acting on them to move them towards the right hand side, okay, to move them forwards. So what we find then is if we apply the same force to different objects, then they accelerate at different rates. And what we see in the pattern there is that the greater the mass, the lower the acceleration will be. Now, if we've got two vehicles that have the exact same mass, the one that's got a greater driving force is going to accelerate faster. Here's our next equation then that we need to be able to use. Remember, they will all be printed on page 2 of your exam booklet, so you don't have to memorize it. So the equation I'll print on page 2 for you is that the force in newtons is the mass in kilograms times by the acceleration in meters per second squared. So because we've got those three things, again, what we can do is stick it into a triangle so that if we need to rearrange it, it's nice and simple. So force goes on the top and then mass and acceleration on the bottom of our triangle there. To give you an example of the kind of question that might come up, we might have one like this here. A cyclist accelerates at 1.5 meters per second squared. The mass of the bicycle and rider is 90 kilograms. What force is the cyclist producing? So we turn to page 2, we find our formula, which is force equals mass times acceleration, and then we put our numbers in. So we know the mass is 90 kilograms and the acceleration 1.5. So 90 times by 1.5 gives us our answer of 135 newtons. If you're asked to work out something that requires you to rearrange the equation, remember the easiest way to do that is to use the triangle. So an example of the kind of question I might ask you there is a passenger jet has a mass of 320,000 kilograms and it has 800,000 newtons of thrust force from its engines. Calculate its acceleration. So we know that force is mass times acceleration, and then if we put that into a triangle to rearrange it, the acceleration is going to be the force divided by the mass. So then we just put our numbers from the question in. So force is 800,000 and our mass is 320,000. So 800,000 divided by 320,000 gives us the acceleration of 2.5 meters per second squared.